In this lesson, we're going to be looking at something called reaction mechanism. Now, when we are dealing with a reaction, most of our chemical reactions occur as a sequence of steps that only involve one or two particles. And this makes sense because when we think about our collision theory, in order for a reaction to occur, the collisions of the particles need to be effective. So if you're trying to have a collision is made with the correct speed, the correct amount of energy, and the correct orientation, and it involves 2 or 3 or 4 different particles, very few of those collisions are going to be effective. So instead, most chemical reactions happen in a series of steps that involve only 1 or 2 particles, maybe 3 particles combining together in a collision. So when we're talking about these steps, the steps have a name and they're called an elementary step. So an elementary step can consist of 1, 2, or 3 particle collisions. It is basically unheard of for a 4 particle collision to happen. So the type of elementary step is unimolecular if it involves 1, bimolecular if it involves 2, and trimolecular if it involves 3 particles combining. When we have a series of elementary steps that combine for a reaction, it combines and forms this thing called a reaction mechanism. So we're going to look at a fake reaction and the reaction mechanism for this fake chemical reaction. So we have this reaction when we have 2A plus 2AB plus C makes D plus E plus F. Now, it is so unlikely that 2A particles and 2AB particles and 1 C particle can collide with all the requirements for an effective collision to create our products. So instead, our products are created in a series of steps. So there's 3 elementary steps for this reaction mechanism. The first step is very slow occurring. The next elementary step occurs much faster, and the third one also occurs quite quickly. If you take a look at our elementary steps and you start paying attention, in elementary step 2, G is created as a product, but then that G is consumed down here in elementary step 3. So this G that is made in one step but consumed in another step is called an intermediate product. So just making a note that sometimes our reactions can produce and consume an intermediate product. So it's an intermediate product because it's not found up here. It's not found up here as part of the overall reaction. The other thing to point out in that in every reaction mechanism, there is always one that occurs with a much slower reaction rate than the others. So our elementary step 1 right here actually occurs very slowly. Because it is occurring slowly, it's the slowest step. This is the step that determines the overall rate of the reaction. So because it occurs slowly, we call it the rate determining step. Okay, so the slowest step in any reaction mechanism is called the rate determining step. So really, it's quite easy. The rate of reaction will always be in brackets after the elementary step. So the one that says slow is the rate determining step. The reason we want to look at a reaction mechanism is because you can use the reaction mechanism to determine the rate law equation. So instead of looking at data of various different trials in your reaction rate experiment, you can look at a reaction mechanism. So it works because the rate determining step impacts the overall reaction rate. And so therefore we can use the concentrations of the reactants of the rate determining step to calculate the reaction rate using the rate law equation. So the way it works is that you can use the mole coefficients, so the numerical coefficients, which we know equals number of moles of each particle of the reactants in the rate determining step, become the exponents in the rate law. So we look at our example here. We have a reaction up. We have a reaction up in here, and we have, so that's our overall reaction, and we have 3 elementary steps. And so our goal is to get a rate law equation. We know that our rate law equation is going to be R equals K, and then something after that. So the first step for getting your rate law equation using a reaction mechanism is that you have to use your initial reactants. When I say initial reactants, I mean the actual reactants in your overall equation. So NO and H2. So they come down here and become part of your rate law equation, like this. So the second step is that now that you have your reactants in your rate law equation, you need to get their exponents. So you use the mole coefficient from the rate determining steps for the exponents. So to do that, you have to know your rate determining step. And again, it's just the one that says it's slow. So right here, our rate determining step is elementary step 1. So we come over to our elementary step, and we're going to do hydrogen first because it's easier of the two. So if we look beside hydrogen, I'm going to do it in pink. There is nothing there, but we know that that's actually an invisible 1. So I'm going to put that invisible 1 in here. And so that invisible 1 comes down here and becomes the coefficient for the concentration of hydrogen gas for the rate equation, the rate law equation. So that 1 comes here. I guess this arrow should continue to here. Now, nitrogen monoxide, however, is not in the rate determining step. So because it's not in the rate determining step, it has a coefficient of 0. And we'll just write that in here. The last thing when you're determining or actually there's 2 more things to look at. The first thing is that we can simplify because we know when it's to 0 order reaction, we don't have to include it. So we can simplify this to R equals K to the concentration of H2. We do not need to show our 1s because we just assume they're there. The last thing though is if you pay attention in our rate determining step, there are a couple reaction intermediates. So the first one is N2O2 is actually produced in step 1 and consumed in step 2. And then another one is N2O is produced in step 2 and consumed in step 3. So because they're reaction intermediates, they're actually not allowed in the rate law equation. So even though they're involved in the rate determining step, they cannot be in the rate law equation. So that's the end of part 1. You are going to have to continue into video lesson part 2 to finish this lesson on reaction intermediates.